Hey everybody, welcome to ASG Astronomy. Today I want to walk through and show our new electronically assisted tilt device. This is what we're calling the EAT. It's a electronic photon cage. I think a lot of people are familiar with our mechanical photon cage, which has been pretty popular. What we've done in the past year is build some prototypes of this unit. This is electronic with 4 motors. And it lets you do high resolution tilting all remotely. It's going to be something I think a lot of remote observatories are going to like. But not only that, a lot of people who don't like to go out in the middle of the night and spend a couple hours in the cold working with tilt, you can do it all from your computer remotely now with software. In the same process, just make the movements electronically. The unit, let's take a look at what you get with the unit. We've designed it to be really lightweight. The head unit here comes in at right around 25 ounces. We've tried to do a mixture of CNC machining. For example, where these 2 plates down here need precision, we've done the machining part. But we also do some carbon infused plastics to add rigidity and also keep the unit as lightweight as we can. You can see it's not heavy at all. This unit works great, for example, in the front of fast astrographs like a ROSA 11. I've been running one of these for about 9 months on my unit, and I'm not afraid to hang this on the front of a corrector plate. It's that lightweight. What we've done to help with that situation is we've moved the computer box to a remote unit. That way you can mount this anywhere you want, keep it off of your optical train, and try to keep this head unit as low weight as possible. Let's take a look real quick at some of the mounting solutions you have. First off, the unit comes with 3 millimeters of physical space. That includes M54 female threads in the middle here. Again, 3 millimeters. We use these little spacer kits from ASG Astro. They're really good. They come with 3 millimeters of thread space. And so if you want to mount something directly to the unit, you can. For example, these work great because they take up exactly that 3 millimeter spacing. I think a more popular solution is going to be either on a ROSA 11, for example, using our 5-bolt pattern. This is a kind of a horseshoe pattern here. That is for our filter slider systems. We use those all the time on our ROSA 11s. It's the same filter system that we use with our mechanical photon cage. So we've tried to build a modular system. This one just, if you have one of those, bolts right to it. We also have standard filter sliders and a few options for that custom pattern. Probably more popular is going to be mounting it to a filter wheel. Most of these come with a 6-bolt pattern on 62 diameter. And you can see this ZWO one comes with 4 of those bolts. It would be these inside bolts. I believe they use M2.5 screws. The same bolt pattern is on QHY or other filter wheels as well. I think they use M3 screws, but our system has M2.5 screws. So if you're going to bolt a filter wheel to it, you just need to make sure you get some M2.5 screws. And this will bolt up to it. Of course, you can rotate it 60 degrees, however you want to mount that to get it to line up with an OAG maybe on the other side. Works good that way. And when you do mount it to a filter wheel, you'll notice it probably is going to cover up most of these other exposed holes. If you need to cover some of these holes, we provide also some little plugs. You can put those plugs in our bolt pattern. We have some little M2.5 set screws. You can glue those in or thread those in. So if you want to seal some of those holes, you can. But you have a lot of options for mounting. I should note too, we also have a 99 millimeter bolt pattern. It's not real obvious, and it's not something that's as popular, but ZWO makes a 50 by 50 filter wheel, but it uses a 99mm bolt pattern. And so if you do have unmounted 50 by 50 glass, you can use that filter wheel, and we do also provide some of those out here as well, 4 of them. So that's kind of the mounting piece. Let's take a look at the unit itself. You'll notice it comes with cable guides. These are these plastic pieces. You can just rotate them or unbolt them, and you can keep cables managed that way. We have those throughout the unit. Inside, between the 2 plates, you'll notice we have this little gasket piece in there. That is going to seal out light leaks. So your camera slides in and it's going to fit down inside of that little gasket. The unit comes with a bunch of other mechanical stuff. There's springs and linears in here and all that. I won't go into that too much. The 4 stepper motors. I know a lot of people are asking what's the resolution of this unit, and the resolution of these motors is about 1.8 microns. So if you're going to do a back focus adjustment and you're going to back the camera out equally, all the motors are going to move about 1.8 microns per step. So if you're trying to adjust that, you can back the unit out with our software. About 550 steps, you're going to be about 1 millimeter of movement in your camera. What we recommend is you take account the 3 millimeters of back focus for this unit, plus 1 millimeter for backing the camera out and giving it room to adjust. So I like to account for 4 millimeters of back focus, and then design my optical train system for that. That will kind of ensure you're in the exact spot you need to be. How much back focus do you have play? I would say give yourself a maximum of about 2 millimeters, maybe 2.5 millimeters. So you don't want to go much further than that, or things will start to separate. It's not a lot. Think of it really as a precision back focus device. Everything else should be done with actual spacers and get you to that 4 millimeter spot. But when you're out at night remotely, you can kind of adjust it in and out using our back focus for precision. On top of that, we have a second camera holder up here. Again, I like the 2 camera mount system like this, where you're clamping a camera in 2 locations, very much like a rifle scope. This is a mock ASI camera. You can see it has plenty of room to grab that. If you use a longer camera, like a QHY, it will work equally as well. It will just stick out a little bit higher. The thing with QHY cameras is they often come with desiccant ports that stick out. And what you can do is use little M5 set screws and put in there. I wrap them in Teflon tape. Some people can put some kind of thread locker on there, something to keep them from going in and out, because a regular set screw just kind of is loose. We also provide some of those if you let us know you have a QHY camera. Some QHY cameras, like the color cameras, often come with a dovetail, and some people have asked, does it work with some of those dovetails? And yes, it does. It will still fit down in there, and the camera, it'll still clamp the camera by the body, just not as much. So those work too. I think the ASIs are much easier to work with because you can just remove their black tilt plate, which is 5 millimeters, and you get down to that 12.5 millimeters of back spacing in your ASI cameras, and it's very easy to work with. The QHY camera is a little bit different. They've got short back focus cameras like this 600, but they still have kind of odd lips to them. You just have to account for that. Look at your setup, look at the mechanical drawings, and figure out what you have. I know some of them also come with a CAA, or a camera angle adjustment piece, and sometimes they have big thumb screws that stick on the outside. You could even get rid of those thumb screws and put set screws, and what that does is is keeps the CAA on there, but it keeps the cylinder shape and it gives you something more to grab. So just play with whatever it is you have to determine your exact back focus on a QHY. They're just a little bit more unique, and there's a lot of variety to them, where the ASIs tend to be pretty generic at 12.5 back focus. So in terms of the unit's dimensions, mounting, that kind of outlines the unit. We do have 4 stepper motors. They're all going to be labeled M1 through M4, and the cabling here is labeled M1 through M4, and then it goes out to the head unit. This head unit is really lightweight, and it just takes a USB and power, just a regular 12-volt power supply, which most mounts have. We really like the Pegasus Astro power boxes, simply because it's switchable power, and I like to turn the power off to the unit when I'm not using it. Otherwise you're sitting there heating up the motors. They're not running, they're not doing anything. The unit is plenty strong. You can see I can't even move it even when the power is not applied. So you don't have to have power to the unit in order to hold it in place. So a switchable power unit will kill the power, it'll kill the heat, it'll increase the longevity of your motors, I think, by not having them sit there and run idle for, you know, sometimes days and weeks or months. So if you can, use power to the unit that's switchable. If you're in a situation where your house, and you know you're going to go a couple weeks where you're not going to mess with tilt, and you have it just plugged in, you can go out there, and I often just unplug mine as well. The USB just provides the brains to the unit, so you could leave USB plugged into it, which is fine to do, or just unplug USB if you don't feel comfortable with that as well. This unit is so lightweight you can either bolt it. We've got some mount systems that go on dovetails, but you can also sticky side tape that, double sticky side that. It's pretty portable in terms of the unit. These cables, I know some people have said, how do I get these unplugged? Just to give you a quick tip here, you know, these little heads on these, obviously you can't push with your finger and get them to unplug. But a really easy technique to do this, if you need to take the unit off, you don't want to take the computer off, you just want to undo your optics, just hold them flat like this in your hand and just take a little Allen head driver, and you can just push on those and they come right out. So very easy to unplug and plug back in. They should snap, they're positive feeling plugs. And again, the motors are identified on the back side of them. Some other things you'll get in your unit, we give you a Velcro strap here if you feel more comfortable putting this around this gap. Maybe you're, gonna leave it at a remote observatory. You might want to do that. It just helps eliminate any possibility of light getting in between these plates. Again, we still have a gasket in there in place for that, so I don't think you're going to get any light leaks. We've done some 5-minute subs in the daylight, haven't seen any light leaks, but if you're going to let it sit and not touch it for a while, throw the little Velcro strap around it. We also give you, where the little slit and clamp is, there's a screw right here just for that, and you can run that screw through your Velcro and keep it in place and know it's not going to fall off or something as well. So something to do if you need to. You don't have to, it's optional. We also provide you with a 3-foot power cord and USB cord. If you need longer ones, you can get those. They're standardized sizes though. Just to take a quick look at the unit though, in terms of how you run it, we've tried to keep it really simple. Again, you're going to want to make sure when you slide that camera in that you have the 4 corners tied to the 4 stepper motor corners. The orientation at which you put the camera in there is important. I like to line up the long edge of my sensor with this clamp right here. ASI cameras come with a little black desiccant port on top of them, that little black button. and you can pop that off. It's just a plastic piece that comes off. But we do make a little recess for that if you want to slide the camera in, and that's going to make the long edge of your sensor line up with a couple of the corners. Now, we also provide a little recess here for a duo focuser. I know the 2600 duos are popular. If you want to, you can slide that in right there as well. Other than that, again, just keep the four corners lined up with the unit, and identify where that long edge is. If it's lined up with this slot, then you know that this is the top or the bottom of your image. It has to be. It has to be one or the other. How it reads into the software is completely different, but at least you know physically that is a top edge. And so when I look at a device like this, I know that clamp, I know if that's top or bottom of my camera. Let's take a look at real quick plugging it in and running the unit. It's just going to take regular USB, plug that in, and I can provide 12-volt power to it. On a Windows, you're going to get a piece of software that looks like this. It just looks like looking at the top of your camera. You can see the clamp ring is right here, and the clamp ring is right here. Inside the software, I give you a way to turn that image 90 degrees. So if you need to put this clamp at the top and make that the top of your image, you can certainly do that. It's just a matter of switching the orientation. All you need to do here, you're going to select the COM port and you're going to hit connect. And when you're connected, it's going to turn green on this light. That means you're now connected to the system, and it's going to read all the corners of the motors of what's stored in the computer. And you can see those show up on the current positions. You can see there's a place to enter adjustments in all axes, top left, bottom right, right left, top bottom, wherever you want to tilt, as well as a back focus adjustment. And the back focus adjustment is just going to move all motors equally up or equally down. So if you put in 500, it's going to move the whole entire unit up, away, 500, which is about 1 millimeter. If you say I want to move it minus 250, it's going to move the whole camera down about 0.5 millimeter. So that's the back focus system. Tilting, it works the same way. If I want to tilt left to right or right to left, I just have to put in, let's say, left, and I can just type in a number, and it's going to move the left up and it's going to move the right down equally. So the center of your image or your sensor is going to be moved, it's not going to be moved back focus wise, it's just going to be moved and tilted. So making tilts doesn't just bring up one corner or bring it down, it actually rotates it on the axis the way it should. And so you don't get back focus changes that way, which is a really nice feature. Okay. If I'm going to type in 500 here, I'm going to move the camera up about 1 millimeter. You'll see the red light, and that means the unit's working. The motors are moving. You can hear it clicking and going off, and you'll see information down here as the unit moves. You can see moving it about 1 millimeter took about 5 seconds to do that. So you have to give it a little bit of time to make its movement. Now you can do another adjustment. You'll also notice the current positions have all changed. And when a move is done, all that information is going to be saved into the computer. Should you lose power, should you kill the power now, it's going to be saved. And so the next time it starts up, you know where the unit is. Okay. There's a couple other options within the configuration. You can rotate the image to give you a different orientation. You can also zero out the motors. So let's say you get this unit completely messed up. You can pull the power to it. When you pull the power to it, you can then push this whole unit down by giving it a little bit of pressure. It takes quite a bit of pressure, but you can push this unit back down and you're going to see that it's now bottomed out again. You know you're at that zero position. Your camera is pushed all the way down, your sensor is down, the rings are as far collapsed as they're going to go. And you can zero the unit out. And what that will do is that will go ahead and zero out all of the positions of the motors. So now you're ready to start again. And what you could do is another 500 move and move it back up 1 millimeter. And you know that's going to put you at that 3 millimeters plus the 1 millimeter to move the unit around. So couple options in the configuration panel to help you kind of navigate the device. It's pretty easy though. Right now you still have to use tools like ASTAP or CCD Inspector or Nina to get your calculations. Just think of it usually with Hocus Focus, for example, I usually pair it with a 1-to-1 relation. So if it tells me to move 25 microns on a side, I'll usually move that unit 25 microns and see where I'm at. Maybe a little bit more, maybe a little bit less, just depends on your setup and what you see as results. The nice thing about this unit is you don't touch it. It sits out in a remote observatory. You can do this in the comfort of your own house. I can do this in Chile. I can do this wherever remotely. And by not touching it, I think you're going to see that you can get down to more precise values with the unit as well. So I think it's a helpful thing. I think you're going to see remote observatories like a tool like this. I mean, without something that helps you tilt, you're really kind of stuck to shimming things, or you're just kind of stuck with what you get when you screw all your things together. And that might be great for some really, really expensive things, but kind of mid-level scopes, you might see tilt in a lot of images just because of tolerances in thread pitches, tolerances in machining. You add up a whole bunch of things within an optical train, there's a good chance you're going to see some tilt. As scopes get faster and faster, obviously a Raza at f2 is more prone to it. You throw in a huge full frame sensor, things just keep getting worse and worse, and unless you've got a tool, it's hard to fix things like that. So hopefully we get to the point where we can release more and more of these. We've got a few units out there prototyping, as well as a few that are out there in remote observatories. So far, the information and feedback we've got has been really good and pretty tremendous. I've been using the unit on a Raza 11 now for about 9 months, and I'm really happy with it. I don't have to go out into the observatory anymore. And at f2, I can get the resolution down to 1 or 2 microns in adjustment. So full frame camera, f2, as fast as I can probably get, and still see really good stars across an entire frame. I'm pretty pleased with it. So anyway, check our website, asgastronomy.com. We'll have more information on there, or just shoot us an email if you have a question. We can go over that as well and see what it can do, what it can't do, and we'll take it from there. So we appreciate you watching. Thanks. Bye.